Welcome to Mysterious Universe. Today, we turn our gaze not to distant galaxies or the farthest reaches of the cosmos, but to a place surprisingly close by. A place we've already been. A place we should understand, but still don't fully. I'm talking, of course, about the moon. It's been more than half a century since humans first landed on its surface, and yet, even with exponential advances in technology, countries and private companies around the world are still struggling, sometimes spectacularly, to stick the landing. From Russia's failed Luna 25 mission in 2023 to Japan's iSpace crash, and India's first failed attempt with Chandrayaan-2. Landing on the moon remains one of the most difficult feats in modern science and aerospace engineering. So what gives? Why is it so hard to land on the moon? Shouldn't it be easier now than it was in 1969? Shouldn't advanced AI, precision mapping, real-time communications, and robotic autonomy make moon landings nearly routine by now? And yet, they're not. Today, we're going to explore why. We'll examine the science, the history. If you've ever wondered why a small step for man still requires a giant leap of technology, keep watching. Like, subscribe, and ring that bell, because what you're about to learn might just change how you see the moon forever. 1. A history of crashes and successes. Let's begin with the track record. From the first attempts in the 1950s and 60s to the robotic landers of today, moon missions have always faced a high failure rate. The Soviet Luna 2 in 1959 was the first human-made object to impact the moon, on purpose, but not softly. It wasn't until 1966 that the Soviets successfully performed a soft landing with Luna 9. That same year, NASA's Surveyor program began a string of robotic landings, many of which failed before finally finding success. In fact, out of the 9 Project Ranger missions aimed at photographing and impacting the moon from 1961 to 1965, only the final 3 accomplished their primary goals. The Surveyor program had 7 missions, 2 failed, 5 succeeded. That's a lot of failure for what, on paper, should have been a relatively simple target, a giant rock just 240,000 miles away. Apollo changed the game. 6 successful crewed landings between 1969 and 1972. But they succeeded not just because of technology, but because of something no robot can replicate: human instinct. Neil Armstrong famously took manual control of the lunar module during Apollo 11 when the onboard computer targeted a boulder field. He landed with just seconds of fuel to spare. That margin of success is razor-thin. Fast forward to the 21st century. India's Chandrayaan-2 in 2019? Crashed. Russia's Luna 25 in 2023? Crashed. Japan's iSpace Hokkaido mission in 2023? Also crashed. Only after its first failure did India achieve success with Chandrayaan-3 in 2023, by learning from its mistakes. Clearly, getting to the moon is one thing. Landing safely? That's another. 2. The moon's gravity isn't uniform. This might surprise you, the moon's gravity isn't evenly distributed. Unlike Earth, which has a relatively smooth and predictable gravitational field, the moon's is lumpy. And those gravitational irregularities, called mascons, or mass concentrations, can throw off the trajectory of a spacecraft during descent. These anomalies were first discovered when early lunar orbiters experienced unexpected changes in velocity and altitude. In 2019, scientists confirmed an enormous mass buried beneath the moon's South Pole Aitken Basin, one of the largest impact craters in the solar system. The mass is about 2 quadrillion tons and could be the remnants of an ancient asteroid's metallic core, or something even stranger. This uneven gravity affects navigation, descent timing, and orbital insertion. A spacecraft might be flying perfectly one moment, then pulled subtly off course the next. And when you're trying to land precisely on a target area in a vacuum, a minor miscalculation can lead to disaster. 3. No atmosphere means no parachutes. On Earth, parachutes slow you down. On Mars, the thin atmosphere, while weak, still allows parachutes to play a major role in landings. But the Moon has no atmosphere. 0. That means you can't rely on drag or friction to reduce speed. Everything must be done with propulsion. A lunar lander needs to go from orbiting at over 3,500 miles per hour to 0, using only retro rockets. And it has to do that with exquisite timing. Controlling descent speed, direction, and attitude with no margin for error. It's like balancing a pencil on its tip while flying at terminal velocity, and doing it blindfolded. The Apollo lunar modules had astronauts to monitor and correct for these factors. Robotic missions don't. Every calculation must be programmed and simulated in advance, and if anything changes, the system must adapt instantly. The slightest overcorrection or delay can result in a hard crash. 4. Communication delay and autonomy. Even though the Moon is relatively close, about 1.3 light seconds away, there's still a delay in communications. Roughly 2.5 seconds for a round trip. That may not sound like much, but it's too slow for real-time manual control from Earth. That means moon landers must operate autonomously during final descent. They have to navigate, make course corrections, and execute soft landings all by themselves. This requires advanced onboard computing, highly accurate sensors, and precise thrust control. Any failure in this automated sequence, any bad sensor reading or software bug, can doom the mission. And as we've seen, it often does. 5. Targeting the South Pole. Older missions, Apollo, Surveyor, and most early lunar landings, targeted the lunar equator. These areas are easier to reach, flatter, and bathed in consistent sunlight. But modern missions are now aiming for the Moon's south pole. Why? Water ice. Permanently shadowed craters near the South Pole are believed to hold vast reserves of frozen water. This resource is vital for future lunar bases, providing drinking water, breathable oxygen, and even rocket fuel. But landing in this region is incredibly complex. The terrain is rugged, steep, and filled with massive boulders. Sunlight is limited and comes at low angles, making navigation and solar charging more difficult. To land here, spacecraft must perform intricate orbital insertions into polar paths, adding another layer of complexity to already challenging missions. It's no surprise that Luna 25, Chandrayaan-2, and iSpace all failed while targeting this region. 6. Propulsive landings are hard. SpaceX makes rocket landings look easy now, but even their Falcon 9 boosters rely heavily on Earth's atmosphere to slow down and stabilize. Lunar landers don't have that luxury. A propulsive lunar descent must be precisely controlled from start to finish. It's not just about firing engines, it's about managing attitude, velocity, and vertical speed in a constantly changing gravity field. And all of this must be done with finite fuel, limited time, and zero real-time intervention from Earth. Even slight errors in burn timing or thrust magnitude can cause a crash. That's why landing upright and softly on the Moon is so technically demanding. 7. Failures teach success. One of the biggest reasons some countries succeed while others fail? Experience. NASA failed multiple times before Surveyor and Apollo. The Soviet Union had years of failed lunar missions before Luna 9 succeeded. India's Chandrayaan-3 only worked because Chandrayaan-2 didn't. Failures are part of the process. Each crash, each malfunction, each miscalculation teaches engineers what to do differently next time. But that also means that new entrants, companies or countries attempting their first moon landing, are at a disadvantage. The Moon is not forgiving. It rewards those who learn, adapt, and try again. 8. Human skill versus machine logic. There's a reason why Neil Armstrong's legendary landing is still talked about. Because in space exploration, human instinct can sometimes do what no computer can. When the Eagle module was headed for disaster, Armstrong took over manually. He assessed the situation, adjusted course, and made a perfect landing, while mission control held its breath. Robotic landers don't get that second chance. If their sensors are wrong or their data is off, they crash. Until we develop truly intelligent, adaptive AI that can think and decide like a human pilot, autonomous landings will remain incredibly risky. 9. The moon doesn't forgive mistakes. The moon is simple and brutal. There's no atmosphere to buffer impact, no weather to disrupt operations, no magnetic field to interfere. It's a stark, silent world of vacuum and regolith. But that simplicity hides danger. If your lander is off by even a few meters, it could slam into a rock or tip over on uneven ground. If you run out of fuel, there's no gliding in for a rough landing, you just crash. If your computer glitches, there's no manual override. Everything must go perfectly, or it fails. There's no middle ground. 10. The future of moon landings. Despite the challenges, the moon is calling us back. NASA's Artemis program, private ventures like SpaceX's Starship, and national efforts from China, India, and others all have plans to return humans to the lunar surface. Success will come, but only through persistence. Future missions will rely on advanced sensors, better mapping, real-time hazard detection, and more adaptive software. AI will play a larger role. New landing technologies, like terrain-relative navigation and optical hazard avoidance, will become standard. We'll get there. But it won't be easy. Conclusion. So, why is it so hard to land on the moon? Because the moon is a paradox. It's close yet distant. Familiar yet alien. Seemingly simple, but deeply complex. It tests not only our technology, but our determination, our patience, and our ability to learn from failure. Landing on the moon isn't just about reaching a destination. It's about understanding that exploration is never easy, and that even a world we thought we knew can still surprise us. As we prepare for a new era of lunar missions, we must remember the lessons of the past. The moon doesn't give up its secrets easily. But for those who dare to try, fail, and try again, it offers rewards unlike any other. Thanks for watching. If this journey sparked your curiosity, be sure to like this video, subscribe to Mysterious Universe, and join us next time as we continue to explore the wonders, both ancient and future, of the cosmos and our place within it.